In this video, we are going to be looking at guided notes for Lesson B, Proportions and How to Scale a Graph. Specifically here, we will be looking at proportions. So let's get started. The definition of proportion is a part, share, or number considered in comparison to the whole. We write this typically as a fraction. Example 1 says if Jack answered 17 questions correctly out of 20, his proportion correct is. So we want his proportion correct. That means the correct number goes on top. So we'd write 17 out of 20. If we wanted to change this to a decimal number, we could, on our calculator, divide 17 by 20. And in Desmos, it gives you the approximation here. It's often good to reduce the fraction as far as you can. So hitting this little fraction will change your answer to a fraction, but not only that, it will reduce it. If we do that here, it gives us the same answer, 17 out of 20. So we know that 17 out of 20 is fully reduced. So we can leave it as 17 out of 20, or we could write it as its decimal form, 0.85. Let's go on with proportions in example 2. Example 2 says 95 students in Math 042C were asked how many hours they spent per week on their math assignments. The responses were organized in the table below. What is the proportion of students who spent 3 to 4 hours per week? So they told us there were 95 students, and if we look at this table, in our first row, it gives us 0 to 1 hours, there were 3 students, 1 to 2, 3, 2 to 3 hours, 9, etc., out to 9 to 10 hours, where there were 10 students. So specifically, we were asked to find the proportion of students who spent 3 to 4 hours per week. So we go to our table and we look at that column. It looks like there were 12 students. Now the proportion would be 12 out of our total, which we're told is 95. And that is it. Now, if we hadn't been told there were 95, we could add the numbers in the table, and that would give us that answer also, so we wouldn't be lost. Let's see if this fraction reduces. So we go to Desmos, and we're going to type in 12 divided by 95. Gives us 0.1263. Now, if we hit this fraction bar, it'll reduce it. This one does not reduce. It'll stay 12 out of 95. So we can leave it as 12 over 95, or we can change it to 0.126. But 12 out of 95 is a perfectly good answer. Now, from your Math 142 class, you will learn about population proportion and sample proportion. To find population proportion, we list that as a lowercase p, and that's R, which is the number of successes in the population, over capital N, which is the number of times the activity could have been tried. Once again, that's in the population. So the total number in the population. Now our sample proportion is a similar formula. The way that we indicate that it is the sample proportion is we put a little arrow like over the p, and we call that p hat. That little arrow is called p hat. And it's, once again, R, the number of successes in the sample, over lowercase n, of course, designating the number of times the activity was tried in the sample. Let's look at example 3. In example 3, it says, in May of 2026, Flagstaff held a special election to ratify the Flagstaff Regional Land Use Plan 2045. Of the 5,911 votes that came in, 3,369 votes voted in favor of the plan, and 2,542 voted against the measure. What is the proportion of people who voted for the land use plan? So the proportion of people, we'll call this the population proportion, who voted in favor was the 3369, and we'll divide that by 5911. That is a perfectly good answer. Let's see if that fraction reduces. Let me see what it was again. It was 3369 divided by 5911. Gives us 0.56995. We'd probably round that to 0.57 if we wanted to write it as a decimal. If we push this fraction button, it'll reduce it, but in this case, once again, this fraction does not reduce. So pushing that will give us the decimal back. And here we could write, nope, wrong one. We can leave it as the fraction or write it as 0.57. All right, thanks for watching this video on proportions. In our next video, we will be looking at how to scale a graph.